Welcome to Journey of the Star, a tale spanning billions of years and countless light years. The cold gas clouds in the far reaches of the space, the explosion of supernova, and the creation of the black holes. Every star tells a story of creation, life, and cosmic rebirth. Today we will explore the stages of a star's life, how these luminous giants shape the universe, and what happens when the star's journey finally comes to an end. Every star begins its journey in a stellar nursery known as nebula. These vast clouds of gas and dust are spread out across the galaxy, are the birthplaces of stars. One of the most famous of these stellar nurseries is Orion Nebula, located about 1344 light years away from the Earth. Gravity pulls the gas and dust together, causing the cloud to collapse on itself. As the material clumps together, it begins to form a dense core. This core heats up over time and becomes hotter and hotter. When the temperature reaches about 10 million degrees Celsius, nuclear fusion ignites in the core. Hydrogen begins to fuse into helium, releasing an enormous amount of energy. This is the birth of a star. At this stage, the star is known as a protostar. While it is still gathering the mass from its surrounding, it is on the verge of becoming a full-fledged star. JWST, known as James Webb Space Telescope, has provided unprecedented images of these stellar nurseries, revealing intricate details of how stars form from clouds of gas and dust. It has also captured rare glimpses of stars in its later stages, such as supernova and white dwarfs, which help astronomers study how stars evolve and die. As the nuclear fusion stabilizes, the star enters what we call main sequence phase, which is the longest and most stable period of star's life. During this phase, stars continuously convert hydrogen into helium in their cores, producing light and heat. Our sun, for instance, has been in its main sequence phase for more than 4.6 billion years and is expected to stay for another 5 billion years. Main sequence stars come in various sizes and colors. Smaller stars like red dwarf burn their fuel slowly and can last for tens of billions of years, while massive blue giants burn through their fuel much faster, living only a few million years. Stars in the main sequence are balanced by two opposing forces: the inward pull of gravity and the outward pressure from the nuclear fusion. Equilibrium allows them to shine steadily for most of their lifetime. But all good things must come to an end. Eventually, a star will run out of hydrogen in its core. What happens next depends on the star's mass. For stars like Sun, once the hydrogen is depleted, the core contracts under gravity, causing the outer layers to expand and cool. The star becomes a red giant, growing many times its original size. In this stage, the stars start fusing helium into carbon and oxygen. The outer layers of the red giant are pushed away by strong stellar winds, creating beautiful planetary nebula. For more massive stars, the process is even more dramatic. These stars evolve into red supergiants or even blue supergiants. They continue to fuse heavier elements in their core, producing all the way to iron. When the massive star can no longer fuse elements in its core, gravity takes over and the star collapses on itself. This catastrophic collapse triggers one of the most powerful explosions, the supernova. A supernova explosion can outshine the entire galaxy for a brief period, releasing more energy in a few seconds than the sun will ever produce in its whole lifetime. These explosions also play a very important role in spreading the heavier elements like carbon, oxygen, and iron across the cosmos, elements that are essential for life. The remnants of a supernova can leave behind a neutron star, and in the case of most massive stars, a black hole. Neutron stars are the incredibly dense remnants of a massive star. These objects pack the mass of the sun into a sphere only about 10 kilometers across. They rotate rapidly, sometimes emitting beams of radiation. These are known as pulsars. For even larger stars, gravitational collapse after a supernova can result in the formation of a black hole, a region of space where the gravity is so strong that not even light can escape. Black holes are among the most mysterious and fascinating objects, and studying them offers us insight into the fundamental nature of space, time, and matter. Stars are not just individual celestial objects. They are the engines that power galaxies and drive the evolution of the universe. They create the heavy elements that make up the planets, moons, and even life itself. Without stars, we would not have the building blocks for the world as we know it. Star formation is still happening in galaxies, like in our own Milky Way. Every time a star is born, it carries on the legacy of countless stars that came before it, continuing the cosmic cycle of birth, life, and death. As we look into the future, the stars will continue to form and die. But what does that mean for the fate of the universe? Some theories suggest that as galaxies exhaust their supply of gas, star formation will eventually cease, leaving behind only dead stars, black holes, neutron stars, and cold, dim white dwarfs. Eventually, in what scientists call the heat death of the universe, even these remnants may dissipate, and the cosmos will become a cold, dark, and lifeless place. But for now, stars continue to light up the universe, shaping galaxies and giving rise to life. Stars are the beacons of the universe, lighting our way through the darkness and giving us a glimpse into the vastness of space and time. Their journeys from birth in stellar nurseries to their explosive deaths reminds us that even in the cold vacuum of space, life and death are intertwined in the fabric of cosmos. So thank you for joining me on this cosmic adventure through the life of a star. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating stories from the universe. Until next time, keep looking up and let the stars guide your way.